Yet again, it is time for Insomnia Math. This is a simple algorithm that I invented several years ago while trying to get to sleep. While the basic procedure of the algorithm involves nothing but simple addition, and we can intuitively come up with a conjecture about the algorithm, it might be impossible to prove. The algorithm involves the prime factorization of numbers. All we need to do is take a number, take its prime factors, and add them to the original number. Then, if the resulting number is composite, we do the same thing over and over until we reach a prime number. Usually we reach a prime number pretty quickly. And for the purposes of this algorithm, if a number occurs more than once during factorization, we add it each time, as we will see with our first example. If we start with 20, we factor it out to 5, 2, and 2, and then add those numbers to the original number. We get 29, which is a prime number. So in this case, just one step in the algorithm and we reach a prime number. Let's look at a number that will take us through a few more steps. Starting with 63, we go to 76, then 99, then 116, and finally to 149, which is a prime number. You can double check my arithmetic if you like. There are more than two integers on the number line, and some of them are bigger than 63. As I mentioned, this started as Insomnia Math, and I think I checked the numbers up to around 200 in my head, trying to get to sleep. Other people have done this algorithm with computers, getting up to 6-digit numbers. But of course, there are infinite numbers, so maybe we just haven't used a high enough number. But I will state my conjecture. This algorithm will always end in a prime. If we start with a googolplex or tree 3 or Ryo's number, the algorithm will always end in a prime. But I also believe there is no way to prove this. There are some easy ways to show that the algorithm can't increase too quickly. The numbers that will increase the most are numbers that are twice a prime, which will increase by a little more than halves, since they are a prime number times 2. After one step, the resulting number will be 3 times a prime plus 2. This number has to be odd, so it can't be divisible by 2, and since it is 3 times the prime plus 2, it can't be divisible by 3. Therefore, the rate of increase in 2 steps will always be less than double. In most cases, the algorithm reaches a prime number before it gets to twice the initial value. But perhaps that is not true as the initial numbers become larger. Maybe some of the chains could be hundreds or thousands of times the initial value, or maybe, indeed, they could be infinite. This puzzle was easy for me to come up with, but seems very difficult to find an answer to.